While Europe struggled with Roman numerals, ancient Indian mathematicians had already calculated pi to 4 decimal places and invented the number 0. This mathematical revolution happened over 1,000 years before European scholars even knew these concepts existed. Welcome to the golden age of the Gupta Empire, where astronomy met mathematics to change human civilization forever. In the bustling city of Ujjain, around 400 CE, scholars gathered in what would become history's most influential center of mathematical learning. The Gupta Empire stretched across northern India, and under rulers like Chandragupta II, intellectual pursuits flourished like never before. Here, in observatories that doubled as mathematical workshops, brilliant minds were solving problems that would stump European mathematicians for another millennium. The most revolutionary figure of this era was Aryabhata, born in 476 CE. At just 23 years old, this mathematical prodigy would pen the Aryabhata, a text so advanced that it reads like science fiction to modern eyes. But Aryabhata wasn't working in isolation. He stood on the shoulders of giants, centuries of Indian mathematical tradition that had been quietly revolutionizing how humans understood numbers and space. The story begins with a simple but profound realization. Gupta mathematicians noticed something peculiar about circles. No matter how large or small, the relationship between a circle's circumference and its diameter remained constant. They called this ratio by various names, but we know it today as pi. While Archimedes had approximated pi centuries earlier, Gupta mathematicians took precision to unprecedented levels. Aryabhata calculated pi as 3.1416, accurate to 4 decimal places. To achieve this, he didn't just rely on geometric approximations. He developed sophisticated trigonometric functions and used infinite series, mathematical tools that wouldn't appear in Europe until the Renaissance. His method involved inscribing polygons within circles and calculating their perimeters as the number of sides increased toward infinity. But pi was just the beginning. The real game changer was something so fundamental that we take it for granted today: the decimal system. Imagine trying to multiply 47 by 23 using Roman numerals. XLVII times 13 becomes a nightmare of addition and subtraction. Now imagine having a symbol for nothing, 0, that could hold place values and make calculations elegant and efficient. The concept of 0 emerged from Indian philosophical traditions that embraced the void, the empty, as a fundamental aspect of reality. Brahmagupta, working in the 7th century, formalized the mathematical rules for 0. He established that any number multiplied by 0 equals 0, and that 0 added to any number leaves it unchanged. These seem obvious now, but they were revolutionary insights that transformed mathematics from a clunky tool into an elegant language. The decimal place value system, using 10 digits including 0, allowed Gupta mathematicians to perform calculations that would have been impossible with earlier systems. They could work with enormous numbers and tiny fractions with equal ease. While European monks were still counting on their fingers and using abacuses, Indian mathematicians were solving quadratic equations and calculating square roots. Gupta astronomy drove many of these mathematical innovations. To predict eclipses and planetary positions, astronomers needed precise calculations. Aryabhata proposed that the Earth rotates on its axis, explaining the apparent movement of stars, an insight that wouldn't be accepted in Europe until Copernicus, over 1,000 years later. He calculated the length of a year as 365.25868 days, missing the true value by just 3.5 minutes. Varahamihira, another Gupta-era genius, refined trigonometric functions to map celestial movements. He created sine tables accurate enough to predict planetary positions decades in advance. These calculations required sophisticated mathematics, logarithmic functions, infinite series, and algebraic manipulations that European scholars wouldn't master until the 17th century. The practical applications were staggering. Gupta mathematicians calculated the circumference of the Earth with remarkable accuracy. They determined that the Earth was approximately 24,835 miles around. The actual circumference is 24,901 miles. They achieved this by measuring shadows at different latitudes and using trigonometry, the same method later used by European explorers. If you enjoyed this story, please hit the like button and subscribe for more untold history every single day. See you in the next one.